Hello everybody, welcome back to my channel. So today we're going to be covering an Excel tutorial. So we've done hypothesis testing previously using the student's t-distribution and then doing t-tests with 1 and 2 tail tests. Today we're going to be focusing on hypothesis testing still, but using the p-value and significance level instead, right? So I have another spreadsheet here. You've probably seen this previously in a different tutorial. We'll be using the same spreadsheet, but we use different variables, so then we're using all the variables and it's not just like it's only reliable for one set of things, right? So today let's use let's use loan amount, and let's go with purpose, right? We'll go with purpose. We're only going to be comparing between two variables, but we'll compare between loan amount and purpose, right? So we can copy and paste that into our second spreadsheet. I've just named it p-value tutorial. You can name it whatever you want. So we have our loan amount and our purpose. Let's say we want to compare people with home improvement and people with credit cards. So what we're going to want to do first is highlight both the columns, select data, click filter, go on purpose. Let's unselect everything because we're only using two, and I think I said credit card and home improvement. So we'll get everyone with credit card as their purpose. Copy and paste that over here. Reset this, or just take this off, and home improvement I think was the second one, right? So I'll copy and paste this. Now we have a lot of stuff here. First of all, I'm just going to deselect my filter, so we have everything here now back in its original area, and we have all this stuff here. This looks a bit scary, right? Some of the people on my course are wondering why you have this. This is just to show that every single loan amount here is to do with the credit card purpose, and every single loan amount here is to do with home improvement purpose, right? You don't have to keep these here, because what you can do is just put credit card. I'll just put CC, and then what you can do is delete this, right? We just need it as an indication for the time being to know what values we're dealing with and what the values in this column mean, right? And then we can do the same here. We'll just put HI for home improvement, right? I'll move this across to here, make it a little bit bigger, and again we can delete the purpose, right? So for anyone on my course with the coursework who's like, why do you copy both? You don't have to, but it's just easier, so then you can then just like add in the title after you've copy and pasted everything, right? So that's being cleared, hopefully. So now we have our two parts. In order to start hypothesis test, we need obviously the null and alternative hypothesis, but before we even do that, we'll get the descriptive statistics first, because it'll give us every single statistical variable that we need, right? So like the mean, the mode, the standard deviation, the scortosis, the margin of error, and stuff like that. So we'll just highlight these two columns. Done this lots before. Click on data, click on data analysis. This pop-up will come up and we'll go and find descriptive statistics. Click OK. Our input range is just C and D, and group by columns, because we're not going horizontal, we're going downwards. That's why it's columns, and we have labels in the first row, so we'll click that option. And then we have output range. We'll put this on F. And our summary statistics, confidence for mean, we'll do 95. We don't really need it for the p-value test, but we'll have it on for now. Should load up as so, and that's perfect. So the reason why also people from my course, the reason why I highlight these two at the same time to get descriptive statistics is, one, it's quicker, and two, you get the data side by side instead of doing it one by one, like clicking data analysis and descriptive statistics and doing the same over here, right? You can just do it in one shot. What you can do, right, is just delete the mean, standard error, load up, because the mean here is the mean here and the mean here. Standard error, it's all the same. It doesn't like change its order every single time, so that's why you can do it simultaneously, right? So we'll just move this one over here, move this title over here, and then double click so that everything's presentable and nice. Right, okay, there we go. Okay, so let's put this into a real life perspective or context, right? If we look at the mean here, there are 5 decimal places. It's at 0.03747, right? You can't have 0.03747 in pounds, right? So what we can do here is go and click home and make the decimal places so that it's only to do decimal places, right? The reason why we're doing this is because we want to put it in a real life context and we don't want to, you know, make it so a value's slightly bigger or slightly smaller. That's why we put it to do decimal places. It's not just because, it's because, you know, you've got to read the context. If this is just generally like whatever, it's fine, it can be whatever. But because we're dealing with, you know, loan amount, so cash, it's better to put it in 2 decimal places, because as you can see, it is 0.374. So if we just left it, it would be 0.37, but because we're dealing with currency, cash, we want it to 2 decimal places, so it changes it to 0.04. Hopefully that makes sense. With the standard error, standard deviation, basically all the statistical things that you have, I like to put them at 4 decimal places, 3 decimal places. Either will do, it doesn't really matter. But yeah, that's just another thing I wanted to put out. So we have our car, or it was a credit card. I'll put I'll put loan amount here actually, and then bracket purpose, and then I'll put credit cards and home improvement, just so it's like easier for us to see, because I might get confused. Okay, so now we have the credit card and home improvement, we need to set up the hypothesis test. So I'll put it down here. I'll just type in hypothesis test. And we need our null hypothesis and our alternative hypothesis. H0 just means null. H1 means alternative, right? So what shall we state, right? Let's go, okay, right. We can see quite explicitly here that home improvement's more. Like, they take out more of a loan than people with just a credit card purpose. But let's say that we're trying to find that credit card people loan out more than home improvement, right? So the null hypothesis will be credit card equals home improvement. Your null hypothesis can literally be anything you want, sorry. There we go. We'll just do mean credit card equals mean home improvement. Your null hypothesis will always have a value equal to some other value. It doesn't change. There's no like more nor equal to. It's your null hypothesis is equals. There's no questions asked, right? So our null hypothesis, or alternative hypothesis, sorry, since we're gonna do a one-tailed test, it can only be more than or less than or equal to or more than or equal to. It's typically just more than or equal, or sorry, it's typically more than or less than, but it can be more than or equal to or less than or equal to. It's the same thing, right? So we'll just type in mean credit card is more than mean home improvement. Also, another thing is, if your null hypothesis states mean credit card on the left side and mean home improvement on the right side, you cannot change this for the alternative hypothesis. If you have, let's say, the mean of fish equal to the mean of squirrels, you can't then make the alternative hypothesis the mean of squirrels is more than the mean of fish, because in your null hypothesis you stated it the other way around, right? So that is another thing. So what we can do now is find the t-statistic. This sounds a bit crazy, but for the p-test, we need to find the t-statistic. So we'll just type in t-stat, and obviously we know the equation is equals the sample mean subtract your test mean divided by the standard error. That is your t-statistic. If you don't know that, go to my other video. I'll put it in a card at the beginning of the video. So yeah, go and check that out if you don't know how to do student t-tests still. And we can also find our critical value, but this time it will be equals t.dist.rt, right? This is for the p-test, because we're doing the p-value test. We use the t-distribution, which is why it's t.dist, and RT stands for right-tailed. So what the p-value is testing is whether the p-value is more reliable than the significance level, or less reliable than significance level. I'll try and put up a diagram like on screen right now. Hopefully I remember to do it because it's kind of hard to explain, but if you see it visually, it makes more sense, right? So, okay, t.dis.rt, we've just said what that is. And then we've got x. Our x is our t statistic. And degrees of freedom is, if you don't know, degrees of freedom equals the number of not sample means, just the number of samples you have, subtract 1. And here it's 4,030, so subtract that by 1, it's 4,029. So that is not our critical value. That is our p-value. Sorry, I don't know why I put critical value there, sorry. Okay, so we have here that our p-value is 0.9999999. And since we're testing with a 5% significance level, sorry, I forgot to mention that earlier. So 5% significance level, we have crit value, if you must, I'll just put slash significance level, will be 0.05. Okay, so we can basically say if we round this up, it'll become 1, right? Yeah, it'll just become 1. So we'll just leave it as is. So we can see clearly that the p-value is more than the significance level, which means there is not enough evidence to reject the null hypothesis. So it works in the opposite way of a t-test, because in a t-test, if the t-statistic is more than the critical value, then you reject the null hypothesis. But here, we don't have enough evidence because the p-value is out of the significance range, which means that it's not a reliable enough test, right? So we can state our conclusion, which means p-value is more than the crit value. Therefore, we don't have enough evidence to reject the null hypothesis at the 5% significance level. In your conclusion, you always have to say don't have enough or have enough evidence to reject the null hypothesis, or you can say have enough evidence to accept if that is the scenario, and then always at the end put the certain significance level or critical, not critical, your confidence level at the end of your conclusion, because depending on the significance level, your answer can change. So it's just to let the person know that it was at the 5% significance level, and maybe this might not be true at the 1% significance level. So hopefully that made sense. We'll do a second hypothesis test using a second example, so I'll just be back in 1 second. Okay, I'm back. So I've set up a new scenario here. We're comparing the mean loan amount between people that already own a house, so have fully mortgaged their house, and people who are still in the process of mortgaging their house, right? So let's see who has a higher mean on average of loaning something. Sorry for the door slam. Can't help that, it's not me. Anyways, let's see. So we'll have our null hypothesis, right? So we'll say the mean. We'll go off what we can currently see explicitly, right? And this time we'll use the 1% significance level, so we'll get a more reliable result. So let's say mean amount loaned by mortgage people is equal to the mean amount loaned by house owners, right? Let's just make it easy. And then our alternative hypothesis will just be more than, right? So we can clearly see from the two numbers over here that, one is larger than the other. That is pretty explicit. But we'll go with this test because obviously that's what hypothesis tests are for. So what we're going to need to do first is find our t-statistic. Now, before I do it, mentally think what values you would use from this table. So I'll give you 5 seconds. If you said for this mean, subtract this mean, divided by this standard error, then you are correct. that is what you do. The reason why we do this is because we've stated initially that our mean amount loaned by mortgage people, our mortgage people is in this H column, is equal to the mean amount loaned by house owners on this G column here, right? If we did it the other way, we would be testing the other way around, which is why, because this is our sample mean and this is our test mean. That's the difference, right? If you switch the hypothesis and alternative tests around, right? Just to make that clear. Hopefully that didn't make it more confusing and makes more sense now. But yeah, that is our t statistic. Now we need to find the p-value. So again, because this is a one-tailed test, we use t.dist dot rt. If we were doing a two-tailed test, we'd be using t.dist.2t because that stands for two-tailed. But because it's the one-tailed test, we use rt. So we have x, which is our t statistic, and comma, the degrees of freedom. Again, this is our sample, this is our test. So the mortgage count is 14,008. So it'll be 14,007 as our degrees of freedom. Okay, so we get a really large number here. We can in turn try and find if it will give us a general. Okay, it's giving us a scientific. What about general? Okay, never mind. So we've got a very, very, very small number here, as you can see. And because our significance level is the 1% significance level, it's so small, we can suggest that there is enough evidence to reject the null hypothesis and to suggest that H1 is correct, right? So this is a very, very small number. You can already tell because it's 1.2992 e to the power of negative 268. I don't want to even count how many zeros there are. So yeah, okay. So our conclusion is that the p-value is less than the significance level by a fair amount. No, I'm joking. You don't have to put that. We'll just put p-value is less than the significance level. Therefore, there is enough evidence to reject the null hypothesis. I'll just put H0 at the 1% significance level. So with the conclusion also, is another thing I wanted to say, is you can also add in context, right? So you can also say conclusion, p-value is less than significance level, therefore there is enough evidence to suggest that the average amount loaned to mortgage people is not equal to the average amount loaned to house owners, right? So that's another conclusion that we could write. Oh, of course, at the 1% significance level, we have to remember that. Okay, so hopefully that made sense. If you want to use the p-value test instead of the t-test, either way it's valid. You can check for yourself with the t-test if you really want, but both will give you the same answer. It'll give you different values, obviously, but it's the same concept, right? So hopefully that made sense. People from my course, if you're watching, you don't have to do both. From what I know, they basically test the same thing. They're both hypothesis tests. They're just two different methods of doing it. So hopefully that all made sense, and I'll catch you guys later.